Welcome back to the channel. Today we are starting with manufacturing processes. In this video, we will have a look at metal casting. In this video, we will have a look at introduction to metal casting, pattern materials, and types of allowances in patterns. Metal casting is a manufacturing process where molten metal is poured into a mold to create specific shapes. It has been in use for centuries and is integral to industries like automotive, aerospace, and construction. The key stages of metal casting include melting, heating the metal until it liquefies, pouring the molten metal into a mold cavity, solidification, allowing the metal to cool and harden inside the mold, extraction, removing the solidified casting from the mold. A pattern is a replica of the object to be cast, used to form the mold. Choosing the right pattern material is critical to the quality and cost of the final casting. Let's look at some commonly used materials. Wood. It is easy to shape and inexpensive, but prone to wear and tear, making it less suitable for repeated use. Ideal for one-time or small production runs. Metal. Durable and good for large production runs, but expensive and hard to modify. It's commonly used when high precision is needed over long-term production. Other materials include plastic, lightweight and resistant to moisture, but with limited temperature resistance. It's ideal for medium production runs, especially when moisture and wear resistance are needed. Wax. Frequently used in investment casting for high precision. It is easy to melt and reshape, making it perfect for intricate castings like jewelry. However, wax is fragile and requires special handling. Patterns are designed with specific allowances to account for material behavior during the casting process. Shrinkage allowance. Metals shrink as they cool, so patterns are made slightly larger to compensate for this. For example, cast iron requires around a 1% shrinkage allowance. Machining allowance. Extra material is added to the pattern to allow for post-casting machining operations. This ensures that surfaces requiring grinding or polishing can be machined to the desired precision. Additional allowances include draft allowance, a slight taper, usually between 1 degree and 3 degrees, is added to vertical surfaces of the pattern to make removal from the mold easier. This is especially important in sand molding. Distortion allowance. Thin or intricate castings may distort during cooling, so the pattern is adjusted to compensate for this. Wrapping or shake allowance. When patterns are shaken to remove them from the mold, the cavity can enlarge. This allowance accounts for that potential enlargement, ensuring the final dimensions are accurate. We've reached the end of this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on other exciting topics.